Hi students, welcome back. Today we are going to solve another interesting LeetCode problem called the first bad version. So in this we will be using binary search to implement the problem efficiently. So let's get started. Let's look at the problem statement first. The problem statement says we are given n versions of a product and one of the version is bad. So from that point, all the versions in that are bad. So let's say we have 1 to n versions and second version is bad. From 2 to n, all the versions are bad because the previous version is developed on the next version is developed on top of the previous version. So the objective here is to return that first bad version. Okay, suppose we have 1 to n versions, then we want to find the first bad version. So to facilitate this, what we are given is a function or an API called bool is bad version that returns whether the given version, the past version is bad or not. So using this function in an array of version numbers, we have to find out the first bad version. So let's look at this with an example. Let's say we are given input n equal to 5. That means the number of versions size is 5. Okay, let's take an array. Let's say we have versions here 1, okay, 2, 3, 4, and 5. Okay, so the versions number of versions is 5. So our array size is 5, and the indices of it would be 0, 1, 2, 3, 4. So what they are saying is the first bad version is at 4. So that means from 4 all the versions are bad. So all these are bad. Whereas before 4 it is all good, which is 0. So our objective is to find the first bad version, which is this thing. Okay. If you clearly observe this input after you transform it this way, it is basically a sorted array. So what we have to find is the first position of 1 in this array. So in such cases, binary search would be really useful. Okay, so let's see how. So instead of searching for one, here the modification we have to do is we have to find the first bad version. So if we transform this array into binary search, it would be like this. We have an array of indices 0, 1, 2, 3, and 4. So for the binary search, we need to take a left pointer and right pointer. So the left pointer would be here and the right pointer would be here. Mid would be 4 plus 0 by 2, which is 2. So in binary search, what do? We at mid, we check if the target is less than mid or greater than mid, and based on that we move to either left side or right side. But in this case we are not particularly finding for an element, but we are trying to find the first occurrence of one. So what we will do is at this point, let's check which is this midpoint. Let's check if it is a bad version or not. So if it is a bad version, that means if the value is 1, that means that can be one of our probable answer. It can be one of our probable answer because there can be a 1 before it. If it is 0, that means left of it is all 0. Okay. So we can eliminate the left side of the midpoint. So that is the case here. So currently our mid is 0. So left of it everything is 0. So what we can do is in the next iteration we can move our left pointer to mid plus 1. So our left will come here. Okay. Now based on that our mid will be 3 plus 4 by 2, which is again 3, and mid would be here. So now mid is here, left is here. Okay. And the array of mid is bad version. So that means this can be one probable answer. Okay. Now we have to adjust right. So that means this can either be the first bad answer or one of the bad answers. So the right should come to mid now. Okay. So in the next iteration, what happens is right will come to mid. Okay. Got it? So now when we are here, then if we check for the bad version, again, this is a bad version because we are at the same position. Okay. And at this position, actually left is not less than right. We already reached the end. So we will just return the left. What do we return? We return the left. Okay. So the way we are eliminating is, let's say we have an array like this. Okay. Left is here, right is here, 0, 1, 2, 3. Okay, mid would be here. So if the element at mid is 1, that means it can be a value in, it can be either the first bad version or a value in the rest of the array, any point. Okay, so since we have one of the points, what we can do is we will move right to the mid value. Okay, that is the case. Whereas in case of left, let's say we have like this. Okay, what is happening is mid would be here. If the mid is still 0, that means everything left of mid is also 0 because it is sorted. So what we will do is we'll just move left to right of the mid. Okay, so and how long will we do with this? As long as left is less than right. Okay, so that is our algorithm. So let's write code for this. Okay, means left equal to 1 and right equal to n. Remember, I am not using 0 and n minus 1 here because our function is bool version. It takes the version number, not the index. I just used indexes for our convenience, that's all. So our algorithm binary search is, as long as left is less than right, what do? We take the mid. For taking the mid, we have to do, instead of left plus right by 2, this is a more optimal way to do it to overcome the integer overflow. We discussed this in the binary search problem we solved earlier. Okay, so we have mid at this point. Let's check if it is bad version or not. Okay, now we know whether it is bad or not. So if it is bad, what do? That means everything before it is also bad. So left of the array is not of any use to us. So we move to the right side of the array, which is we make left equal to mid plus 1. Okay. Otherwise, if, or we can just do a else. Okay. Otherwise, if it is 1, that means there can be few ones before it or it can be a first one. But everything after it, the ones which are after it, we can still ignore because we have one probable answer. So, we just move the right to mid. Okay, remember here we can't do mid minus 1 because mid also can be one of the probable answer for us. Okay, so we will do this as long as left is less than right, and once we are done with this, our left will have the answer. Okay, we just return the left. Let's run it and see. Yeah, let's submit. Yeah, so it is accepted. So the time and space complexity of this would be, this is the exact same algorithm as binary search. We only modified these cases a bit to get the first one, first occurrence of 1. Okay, so it will be same as binary search, which is time complexity would be order of log n. Okay, order of log n, and space complexity would be, we are not using any extra memory, so order of 1. Order of log n because every time we reduce the input size by half. Okay, that's all. Hope you understood this implementation of binary search. So binary search is a very powerful algorithm. Like this, it will be useful in many problems. So if you haven't seen our previous video on binary search, do go through it to understand the binary search first. So as always, keep practicing and improving your problem solving skills. If you have any questions, leave them in a comment and we will respond. So please like, share and subscribe. Happy coding!